Okay, today we're going to take a look at angles and polygons. This should be a review of the different types of polygons. You should already know this. And then we're going to go look at interior angles and exterior angles and some formulas that deal with that. So first thing we want to do is a little review, matching up the different parts. If you would say the name as you drag them over. And Brian, why don't you start with this?
The A-sided polygon is the octagon. And a 9-sided polygon would be the nonagon. The 6-sided polygon would be the hexagon. And the 3-sided polygon would be the triangle.
Good. And Kenny, you can come up and do the next 4. And then once you get done with those 4, we will want to check, so go ahead and check it.
The 7-sided polygon be the heptagon. The 4-sided polygon be the quadrilateral. This is why I get a bit of midget. The 5-sided polygon will be a pentagon, and the 10-sided polygon will be a decagon.
Fantastic. Why don't we hit check just to make sure we have them all correct? There you go.
There you go.
There we go. We can mount it a little bit lower maybe. But yes, we have them all correct. So that should be a review for you. Today what we're going to actually go through and talk about is the sum of the measure of the interior angles of a convex polygon with n sides. We talked about convex and concave. Remember, concave had dented sides. Convex doesn't have any dents in it. And the formula that we need to know here is n minus 2 times 180. So let's do a practice problem here with this. We want to find the sum of the measure of the interior angles of a hexagon and also the sum of the interior angles of an octagon. Hexagon has 6, octagon has 8. So go ahead and plug those in. And Carly, why don't you use the pull tabs here to expose each of the answers. Okay, so you should have found that the hexagon, the sum of the interior angles is 720. And an octagon, the sum of the interior angles is 1080 degrees. So thank you for that, Carly. Good job. We also talked a little bit about what regular polygons were. A regular polygon is when you have all of the angles and all of the sides congruent. Notice here that this octagon is a regular octagon because all sides are congruent and also all angles are congruent. So let's take a minute to work through this problem. This is the regular pentagon. Pentagon has how many sides? 5 sides. So what we need to do first of all is find the interior angles, find the sum of the interior angles, and then we'll go through from there and develop a way to solve for x. So when I go through, s equals, the number of sides is 5 minus 2 times 180, right? 5 minus 2 is 3. 3 times 180 gives you 540. So the sum of the interior angles is 540. Now what we're going to do is, if one angle is 3x and it's a regular polygon, that means that all angles must be 3x. We know the sum of the interior angles is 540. In terms of x, how much is it? 15x. So now we'll go through and we'll say then 15x equals 540 degrees. So when we go through and solve, we divide that out and we come up with 36. And 36 then is the answer for x. Questions on that? Okay. So we looked at the interior angles, the sum of the interior angles, and then we're able to find values of x, or we're able to find each interior angle by using the idea that we just did in this example. The last thing that we want to talk about is the sum of the measure of exterior angles of a convex polygon. That will always be 360 degrees. It doesn't matter how many exterior angles there are, it will always add up to 360 degrees. So here I have my pentagon, 5 sides. Here's an exterior angle from each piece of the pentagon. I want to show you visually that this does turn out to be 360 degrees. So if I take this exterior angle, angle 1, and I drag it down here, we're going to fill in our little pentagon down here, and we're going to look at these exterior angles. Dana, you want to come up and do 2, 3, 4, and 5? All you need to do is take your finger and drag it onto the correct color. There you go. And do you see what's happening? We're looking at each of the exterior angles, which is the point at the center here. So as you go through, what actually happens? Well, I end up with a circle, and we know how many degrees there are in a circle, correct? How many degrees are there in a circle? 360. So you can see here that the sum of the exterior angles of this pentagon will be 360 degrees. Okay?